Hello friends, welcome to my channel again. We are watching lecture series on distributed system and resource management. Today we are going to see the different types of clock synchronization. So there are the three types of clock synchronization: physical clock synchronization, logical clock synchronization, and mutual exclusion synchronization. So we will see the first type, physical clock synchronization. We know that in distributed environment, multiple nodes work simultaneously. Every node has its own clock, so we can say that each node operates with its own clock. So there are, we can say that, some drawbacks that gets generated due to it. So this may lead to time differences. So if the nodes are working and with their own clocks, so obviously one node might be showing some different time, another node might be showing some different time. So this is my one node. If it is showing time 9:33, another node might be showing time as 9:33:46 milliseconds. Another node might show the time like 9:35:36 milliseconds. So likewise, so this will result into time differences. The goal of physical clock synchronization is to overcome this challenge. We need to overcome this challenge which is posed due to the time differences. So this time differences will make it's very difficult to synchronize the nodes and execute the events in a time-stamped order. So here one remedy can be there. Each node with the clock is adjusted to match with the universal coordinated time, which is also known as UTC, universal coordinated time. So UTC offers reference to all nodes. This may help to solve the problem of physical clock synchronization to some extent. There are few algorithms that can be used or that we are going to learn in under physical clock synchronization. The first algorithm is Christian's algorithm. Second algorithm is going to be Berkeley algorithm. And third algorithm is going to be NTP algorithm. So these three algorithms we are going to see in next session. So now, second type of clock synchronization is logical clock synchronization. As we are aware that physical clock synchronization was dealing with the physical clocks which are running on different machines. But in logical clock synchronization, it prioritizes the order of events than their exact time. So here order of event is going to play a crucial role, order of events. So there won't be physical timing, but there will be order of events with proper time stamping. So with proper ordering of tasks, it seems to be a choreographed dance where steps are sequenced for executions. The events will be ordered. So it will like be a choreographed dance. We know that when we do a choreography for a specific dance, there is order of steps. So here also we are going to do ordering of the event. The events will be ordered according to their timestamps. It focuses on the order of events than relying on absolute timing. So event will be treated with their order. We will not deal with the absolute timings. It facilitates coordination within the distributed system. So this in under logical clock synchronization, we are going to study one interesting algorithm which is known as Lampert algorithm. So in upcoming session we will discuss about it. This is what logical clock synchronization. So now let's move towards the mutual exclusion synchronization. Third type of clock synchronization is mutual exclusion synchronization. One major concern in the distributed system is managing the shared resources. We know that if the environment is distributed, so multiple devices will be there and those will work parallelly in that distributed environment. So if there is a shared resource and if multiple devices are trying to access that shared resource, then that may create a mess, huge mess. Suppose one memory is there and all devices are trying to access that memory only. So some devices may want to write the data inside the memory and some devices may want to read the data from that memory. Obviously, if device A is there and if device A is writing data into that memory and B device wants to read the previous data. If A device is earlier, suppose C is there that is written inside this memory. Now A device wants to write something X over there, but B device parallelly wants to read that C. Okay, so if A device has written X over there, then C will be overwritten. So whenever B will try to read the data, it will get X back. But what is expected that B device should get C, right? So there will be such type of problems in the shared environment whenever the resources will be shared. So that is going to create a mess. In distributed system, we can say that multiple processes often compete for shared resources and that too simultaneously. So that is going to create a big mess if it is not handled properly. To address this issue, mutual exclusion enforces the mechanism for accessing the resources. So this is what the mutual exclusion synchronization. We are going to see few algorithms under the mutual exclusion synchronization. The first one is going to be Lamport's algorithm. Second one is going to be centralized algorithm. Third one is going to be distributed algorithm. And the fourth one is going to be token based algorithm. So these algorithms we will see in the upcoming session. Thank you for watching the video. If you are having any doubts, kindly put it into the comment box. I will try my best to answer your questions. So kindly like the video and share it with your friends. Thank you.